Okay. So, oh, I got erase the board. I'll do that in a moment. So let me do this for you guys. I'm gonna write out all the steps or label the steps and then have you guys kind of figure things out eventually. Yeah, so right. So let's do this. Hey guys, quiet please, thank you. So we'll say angle ABC is congruent to angle KLM. Let's also say BC equals 8. LM equals 16. AB equals 3. LK equals 6. Also, we'll say and then we'll say this. Okay. Let me erase the board. So what would you put as the reasons 1 and 2? Yeah, both were given. How do I know ABC equals KLM? What was the big tell or giveaway? No. For the first step,
Given.
it's given because you're given that both of them are 40, so they have to be equal. Yes,
The second one's
always
two.
correct. That could happen too. So I totally would say given for the first two reasons because it's clearly in the diagram. So those are like 3 points. Now we're trying to prove that the triangles are similar. I think we kind of know now just by looking at it that the sides are proportional. But before I conclude that triangle is similar, we have to make a statement about the sides. So how you, Ollie, what do you want to say? Yes, keep going.
8/16.
Yes.
AB over KL equals 3/6, and that equals to 1.
Correct. So we know BC over LM. Perfect. Thank you for doing that. We know this is true just by simple math. Because if I divide both sides, both pairs of sides, right? Every single time I divide those pairs of sides, it's going to come out to 1/2, right? For example, BC over LM is 8/16, 1/2. AB to LK is 3/6, 1/2. Because I'm dividing things, dividing some things, and those things I'm dividing are the same. There you go. Yeah, go, yeah. I thought you were pointing something like this one there. Or someone watching me. But maybe Stioli or my department chair. All right. Okay. What was that? ABKL? Oh, I don't care how you when you compare ratios, that doesn't matter. That doesn't matter. It's only that when you state the similarity that matters. That's all that matters. Because you have to make sure the letters correspond when you state the similarity. But the step 3 makes sense. Like we had to divide the sides and we had to say they're equal. And when you do that, because you're dividing and they're equal, the names should be implied of the reason division property of equality because I'm dividing and they're equal. So hence division property of equality. Then I can prove the similar, right? But for what reason? What would be the reason I would state? SAS, yes. SAS similarity, correct. So we'll keep doing proofs this way until you guys have the confidence to do it all from scratch. That's when you're going beyond the similarity. Like once you prove the triangle is similar and you want to tell me more about it. Oh, like what about AC and KM? Like I want to say they're proportional. Then I would have said that. Or if I want to say, oh, angle C and angle M are the same. So corresponding angles of corresponding triangles are congruent. That'd be CAT, STC, or the corresponding sides are proportional. I can't remember that one. CS STP, I think that's corresponding sides of similar triangles are proportional. But we didn't ask that question, so we don't worry about it. Yeah, we're just trying to prove similarity. Okay. All right, so now look at the triangles below. It says below are 6 triangles. Okay, awesome. What else it says here? None of which are drawn to scale. So don't go based off looks. Go based off hardcore evidence, right? The proof here. Among the 6 triangles are 3 pairs of similar triangles. Great. Identify similar triangles with correct similarity statements and name the similarity condition. AA, SAS, SSS. Use to determine this. Put an asterisk next to the pair of triangles that are congruent. How do you know they're congruent? Okay. All right, so let's see here. So they said among the 6, only 3 are actually similar. Okay. So 3 pairs. Okay. All right, so let's look at ABC. Which one do you think is going to line up? Like, let me zoom out a tad. That's better. Okay. I don't like that. Let's try 90%. A little better. All right. Cool. So let's look at ABC. Yeah, go Faye. Oh, I thought you had a bathroom again. You're good. All right, let's look at ABC. Which of these 5 other triangles do you think will be similar to ABC? Go, Ollie.
KJL.
Correct. I'm not going to color code because I have that capability. Yeah, because that's going to be 36 right here. So that's 36 right here. Oh, I'm sorry. I was jumping the gun. You're right. That's 54. And that's 36. Cool. Okay. Yeah. So those are similar. So I'm going to say triangle ABC is similar to triangle. Now, I got to stay in the right order. If I go ABC, 90, 54, 36, then I'm going to say KJL. Because K goes with A, J goes with B, L goes with C. And that's going to be AA similarity. Okay. Cool. All right. So how about this? Why don't you guys try the other 2 pairs? I'll freeze the screen and we'll compare in about 2 minutes. Try to find what is similar to DEF and what's similar to SQR and give the reason and state it the right way in the proper order. There's not, I mean, I didn't have to say ABC and KJL. I could have said CBA and LJK. I could have done BCA and JLK. I could have done all those, but I had to make sure all the letters lined up perfectly with each other, right? So go and try to find the other 2 pairs. I'll freeze the screen and then notice.
I found all of them together. So there's one. It doesn't matter, like, what, they're not faster.
Wait, Mr. E.
Stop.
Could these 2 be similar?
Which one?
SRQ and everything.
Yeah, you got it. Yeah, you got it.
Then, right? It's one of the stuff. Yeah, those two, but. Those two, they're not downstairs, and also you include that. What, bro? Yeah.
Let's see here. Here we go. All right, so hopefully you got that. D, F, and then P. Triangle side. You could have said FED, PMN, I don't care. Make sure D goes with N, E goes with M, F goes with P. Then on triangle QRS and triangle IGH. Side, side, side proportionality because all the sides follow a 2-to-1 ratio, looks like, or 1-to-2 ratio. Again, Q goes with I, R goes with G, S goes with H. So there we go. Yeah, go, yeah, go. Okay. Are these triangles similar? By what condition? What do you guys think? For 97. Yes or no? Yep. Yes. SAS similarity. That's because they're a 2-to-1 ratio. 2-to-1 ratio. That makes sense. Okay, we're cool with that. All right. Then Charles and Lisa. So interesting way of writing Lisa. Write similarity proofs. Charles has that CAT RUN. Lisa has NRU to CTA. Who is correct? NRU. Hold on. I'm confused. Give me a sec here, guys. Hold on. Well, definitely Charles is right, but oh, wait one sec. Wait. 8.2, 16.4. I don't think Lisa's correct. No, she's not. But the Ansky says that they are. That makes no sense. Yeah. So Charles is correct. Oh, 8.4 over 4.2 is 2-to-1. I'm dividing these two sides. That's all. Yep. That's it. I'm just dividing those sides. So it's 2-to-1 or 1-to-2, your choice. So Charles would say yes. That's because Charles said yes because angle C is congruent to angle R. Angle A is congruent to angle U. And angle T is congruent to angle N. Now N doesn't go with, N does go with, yeah, N goes with T, not with C. That's weird. So Lee says no because the congruent angles don't line up. Congruent angles don't line up. Are they congruent? Yes. The reason why you can say they're congruent is because, actually, no, sorry, that's no. Why did I say that? That's stupid. No, because sides are different. Of course, I should know that. Because side lengths
They're similar, but they're not.
are proportional, not congruent. And let me add a little extra word in there. Corresponding. The corresponding side lengths are proportional, not congruent. So notice that RU corresponds to CA. RN corresponds with CT. UN corresponds with AT. Those are not the same. They're just proportional, just 2-to-1. So you can't say triangles are congruent, but you could say they're similar, right? And find the missing side length. Let's say we call this x. So 2 over 1 equals 12.2 over x. You guys see how I set that up? Because everything's 2 to 1, right? So x will have to be 6.1. So I call it missing side x. Ooh, that's a good one. Okay, let's do 106 together. Also have someone read it. But before I move on, any questions on 397? No? Okay. Well, good. Okay. So after this, we'll do one more example. Then for the rest of the class, for those who are preparing for the retake later this week, you guys can use the time for that. There's supposed to be a Delta Math assignment, which hasn't been created yet. I'll look at Mr. Davidson's page. If not, I could create it while you guys are working. And for those who are not doing the retake, but have other stuff to do, that's totally fine. But we should be done in a few minutes, and then we'll have another 15 minutes left after that. Yeah. Sure. Yeah, go for it. Okay. So questions on 397 are okay? Similar triangles all make sense. All right, let me freeze that. I know some people are still jotting stuff down. So if someone can read, so Connor, I'm gonna have you practice your acting voice because you got a big day, big week coming up. Can you read 106 for us?
Latoya was trying to take a picture of her family in front of the Big Ben clock tower in London. However, she snapped the photo. After she snapped the photo, she realized that the top of her father's head exactly blocked the top of the clock tower. While disappointed with the picture, Latoya thought she might be able to estimate the height of the tower using her math knowledge. Since Latoya took the picture while kneeling, the camera was 2 feet above the ground. The camera was also 12 feet from her 6-foot tall father, and he was standing about 930 feet from the base of the tower.
Okay, cool. Yeah, so let's doctor up this diagram. So here's what we're gonna do to doctor this up. We're gonna draw some sides.
Two to 6, 12 to 9.
Yeah, Bruce, we're gonna do that, but let me just draw this first. But yes, you are correct. So if I think about it, that's 2, and that's 2. And I'll call this x. And I'll call this and we know it's 4. Okay. And then also this is 12. So if I draw the triangle again, it's gonna look kind of like this.
Why do you know that one? How do you know that's that one for sport?
Because if dad's 6 feet tall, it's very the camera is very 2 feet above the ground. That's all. So I know. Let's go and label. So you have ADE.
So it's AA. Huh?
Yeah, it's totally gonna be similar by AA. So actually I'll do it over here. Yeah, so you have AA similarity because they both also have these triangles, these angles congruent. So if you want to compare correctly, you can say AD over AB equals ED over CB. Does that make sense? Right? AD to AB, DE to BC, the way I doctored up the diagram. So from the father's like maybe knees to his head, it's 4 feet. I don't know if you want to call it that. For the clock tower, obviously there's 2 feet above the ground. There's the rest of the clock tower, that's X. So if you substitute correctly, 12 over 942 equals 4 over X. Cross multiply 12X. Don't do this in your head. So confirm. So 37, because don't do 942 times 12, is it? Sorry, 942 times 4, is it 3768? Is it correct? I was right. Oh, cool. Yeah, suppressed, I know. All right, thanks. What's that? I don't know what that is. Oh, okay. I got it, got it. And I think that's gonna be don't tell me, 314. Yeah. I did because I divided 942 by 3, just so you know. Anyhow, yeah, so it's 3 and 14. But the clock is not 314 feet tall, guys. Okay, please let's focus because I don't know if you guys missing this on a test. It's not, don't put 314 as the answer. What's the true answer for the clock tower, the height? It's not 314, it should be 3. Yes, because you have to add the extra 2. So the true answer for the clock tower and here's the other issue too. Well, I guess we'll go with feet. But in England, did he use feet? These meters. I know, but she probably just, these are American tourists. Yeah, 6 feet tall. They say her father's like 2 meters tall. Don't forget to add 2. Make sure you don't forget to add. So, okay, cool. All right, those are the notes for today. We're, I'll get your question in a moment. But for those who, you guys got the retake packets. I think everyone got them. So you guys can work on that. If you have questions, ask. I don't have any new materials right now, but I might produce a Delta Math sometime later today for those who are doing the retake next this coming Thursday. Sorry. And I think some of you guys already responded to my email. If you didn't, I'll chase you down or find you. So yes, it is Delta Math. I need to make it right now. So give me about 5 minutes to make the Delta Math. Just hang tight. So yeah.
My head is just so.